that selfies could become a valid procedure within the process of diagnosis and follow-up of patients. With the right applications provided with clear instructions, even the elderly might be able to take some clinically valid selfies. Same for the stereophotogrammetry, where we are combining the captures of different camera perspectives. Is that these systems are really expensive, but also their mobility is rather limited. So since smartphones and their cameras have been improving over the past years, smartphones might be a possible solution to overcome the drawbacks of the classic stereophotogrammetry devices. So some recent smartphones have already some special three-dimensional cameras. Here the LiDAR camera is also very important. That the smartphones are a lot cheaper, of course, than the expensive classic stereophotogrammetry devices. Their mobility is also a lot higher, or one of the advantages is that these devices are easier to use. We compared the Vectra H1 camera for the stereophotogrammetry to different applications, which are called the Heges 3D scanner, Bellus FaceMaker, ScandyPro, Scaniverse, and also Trnio. We did this comparison based on two-dimensional, but also on three-dimensional measurements. We were also taking other important parameters into account, the amount of details, the cost of the applications, the time that is needed for scanning, but also for processing the scans, and also the ease of use of the applications. All 50 participants, 8 different morphometric markers were applied to the subject's face. All scans were made in a standardized environment, and the different scans could be taken by the use of the Vectra H1 camera and the tablet with the different applications. So then the STL files of the facial scans then be uploaded in the Materialise software 3DBodyTech. Of course, the registration could be done of the different smartphone application scans on the Vectra H1 scan, and we did 8 different measurements of the distances between the specific morphometric markers on the smartphone application scan and the corresponding markers on the Vectra scan. For the three-dimensional markers, we delineated 4 different zones of the face. We saw that these different regions could have some slightly different accuracy measurements depending on the specific smartphone application. To carry out the three-dimensional part comparison analysis. And by doing this analysis, we were able to measure the average distance over a particular zone between the smartphone application scan and the Vectra H1 scan. Scans taken by the Bellus FaceMaker, Scaniverse, and Trnio applications were having the lowest distances to the Vectra H1. There might be some higher variability within specific morphometric markers. A possible explanation for this variability within these zones is the technique of smoothing. The applications Bellus FaceMaker, Scaniverse, and Trnio are having the lowest distances to the Vectra H1 scan. Then the three-dimensional measurements, these measurements are also confirming the results that we got from the two-dimensional measurements. So here we see again that the scans of the Bellus FaceMaker, Trnio, and Scaniverse are having the lowest distance to the Vectra H1 scan. Overall, we can also see that almost all measurements of all applications, except from the ScandyPro applications, are lying below our threshold of 2 millimeters for the clinical usability. But there are also some other parameters that we need to take into account, the amount of details that the application is able to process, and therefore the Heges 3D scanner and Trnio applications and the cost. So as Trnio and Scaniverse are free applications, that the time that is needed for scanning, but also for processing the scans. Their Heges 3D scanner and Bellus FaceMaker are in need of the lowest amount of time, is the ease of use of the application. And there the Bellus FaceMaker was doing best. So in conclusion, smartphone applications might be clinically useful. They were lying below our threshold of 2 millimeters. Regions, we see that the forehead is having the lowest variability, and the chin and cheek regions are having the highest variability. With this research, we are already one step closer to the bedside scanning, where we are really looking for in clinic.